Greetings everyone, and welcome to this walkthrough where we explore some of the powerful math tools available in Python through the built-in math module. This demo focuses on applying real-world math operations using code, covering topics such as geometry, rounding, exponential growth, and precision comparison. Let's get started by importing the math module. You'll see that right at the top of the file. Import math. This provides us with access to a wide variety of mathematical functions and constants, much like having a calculator built into our code. Our first example is a geometry classic, calculating the area of a circle. We've defined a radius of 4, and we use the formula for calculating the area of a circle. But instead of typing in the number 3.14, we use the math pi value, which is Python's super accurate version of the value of pi. The formula becomes pi times the radius squared. When we print it out, we get the exact area with full decimal precision. This is great for science and engineering tasks where you need that level of detail. Next up, we use some foundational functions, square roots and powers. We take the square root of 16 using the math square root method, and then we raise 2 to the power of 3 using the math power function. These are perfect when working with measurements, scaling, or any formulas in physics and statistics. Now let's shift to logarithms. These are incredibly useful for analyzing data or scaling values. We calculate the natural log of 100 using the math log function, and then we use the math log 10 to obtain the base 10 log. If you're diving into finance, science, or even machine learning, you'll definitely run into these functions. After that, we handle rounding. Python gives us 3 main rounding functions: floor, ceiling, and truncate. We use them to round a decimal number, 5.73. The math floor method gives us the next lowest integer. The math ceiling function gives us the next highest integer number. And the math truncate function simply chops off the decimal part. This kind of control is essential when you're formatting numbers for output or working with prices. Then we take a look at absolute values. With math fabs, we take a negative number, negative 8.9, and convert it to its positive equivalent. This is helpful for tasks such as measuring distances or differences where direction doesn't matter. Now here's something interesting. Floating point precision. If you've ever added 0.1 and 0.2 in Python, you might be surprised by the result. It's not exactly 0.3. That's due to how floating point numbers are stored in memory. To handle this, we use the mathIsClose function to check whether 2 floating point numbers are close enough to be considered equal. This is a best practice whenever you're comparing floating point results. And finally, we explore exponential growth using the constant mathE function. We use the mathExp function to calculate e to the power of 5. This is how you model things like population growth, compound interest, or the spread of a virus. Anytime growth accelerates over time. Throughout this demo, we've seen how Python's math module makes powerful calculations not only possible, but incredibly easy. Whether you're working on a school project, solving scientific problems, or analyzing data, these functions will become your go-to tools. So keep this video as a reference. Experiment with the values and try swapping in your own scenarios. That's how you'll really learn how math and programming go hand in hand. Thanks for following along. We will see you in the next video.